Welcome to VD Academy. Today we'll discuss about our next topic, that is classification of wave. Let us proceed. Wave. Where am I? It's matching, I think. Okay. Based on, first of all, first category is divided into based on medium. Second category is based on motion of particles. Third one is again based on EP, based on energy propagation. Fourth one is again based on direction of propagation. Direction of propagation. So let us proceed. Okay. Yes. Okay. Next one is again is further classified, or else first of all we can discuss the short form, that is medium. It is based on the MOP, that is motion of the particles. Again, third category is again energy propagation, and fourth category is nothing but DOP, that is direction of propagation. Again, it is further divided into two parts. Each of them are divided, most of them are divided into two parts. Third one is again energy propagation is also divided into two parts. Last but not the least, it is divided into again three parts. Let us see based on medium. First category is that is mechanical wave. Mechanical wave. Second one is again EM wave, that is electromagnetic wave. Electromagnetic wave. Third one is again longitudinal wave. Fourth one is again transverse wave. Fifth one is again progressive wave. Sixth one is again stationary wave. Seventh one is again 1D wave. Eighth one is again 2D wave. And last one is again 3D wave. You can also elaborate it as well. Like 1D wave stands for one dimensional wave. One dimensional wave. 2D stands for two dimensional wave. Two dimensional wave. And again 3D stands for three dimensional wave. Let's proceed again. So here in short you can write it as an ME. You can term it as an LT, MELT, progressive and stationary, and 1D to 1, 2, 3D. Like you can memorize it as well in this way. So let us continue further. So let's move on to the next page. Hope so you are understanding the classification. You can take the screenshot as well. Okay, let's continue. So you can see here, as per the about tree diagram, as per the above tree diagram, as per the about tree diagram, primarily waves are classified into how many types, my dear students? Into four types. Let us see what are those types again. A stands for P stands for what? C, that is third category. D is fourth category. That is, or you can we have termed it as an 1, 2, 3, 4 at the first level. Okay. Okay. So first one is that is based on medium, that is M to memorize. Second one is based on motion of the particles. Motion of the particles of the medium. Motion of the particles of the medium. Of the medium. That is nothing but MOP. You can term it as an MOP. Third one is nothing but that is EP. based on energy propagation, energy propagation, that is EP. And last but not the least, it is basically divided on the basis of direction of propagation, DOP, direction of propagation. That is, in short, you can write it as an DOP. Again, now we'll discuss one by one each category. Like that is the first category we are going to discuss, that is based on medium. Based on medium. Let us see. Again, on the basis of medium, on the basis of, wait for a while, take the color. That is, okay, on the basis of medium, on the basis of medium, on the basis of medium, waves are of two types. What are those types? In the previous T diagram, we have already discussed that as number A, or first one, that is on the basis of we can memorize this as ME. That is, M stands for mechanical wave, and B stands, second one is nothing but EM wave, that is electromagnetic wave, that is electromagnetic wave. So let us discuss about, first of all, discuss about mechanical wave. Afterwards, we'll discuss about the electromagnetic wave. So let us see. First one, properties of properties of mechanical wave. Let us discuss about the properties of mechanical wave. Let us discuss the first point. So in this, first of all, the property of mechanical wave, first one, energy and momentum propagates, energy and momentum propagates, propagates, propagates by the motion of particles, by the motion of particles of the medium, but the medium, but the medium, but the medium, medium does not, medium does not propagates propagates but the medium does not propagates, that is the transfer of mass does not doesn't takes place doesn't takes place means what happens, my dear students, in this the energy, you know that what is energy we are already discussed, that is E is equals to mc square, or anything, any object that contains matter, it contains energy, whether it can be of any of the form like kinetic energy or the potential energy, or you can also transfer it as a momentum, that is given by p is equals to mv, that is mass into velocity. Okay, next let us continue. So you can see here what happens in the mechanical wave, what happens in this type of waves, energy and momentum is propagated by the motion of the particles. In this, what happens? Particle is what? Moved from one place to another. But actually, the mass does not transfer. It is not transferred. So, let us see the further properties. Due to elasticity, due to elasticity, due to elasticity, what happens? Of the medium, due to the elasticity of the medium, or you can say that by the usage of the medium, particles, each particles occupy their original position. Original position. What happens in terms of mechanical wave, my dear students? What happens? Like suppose it is a particle number P1, it is the P2, it is the P3, and it is a P4. It is prolonging in the forward direction. Okay, it is prolonging in the forward direction. But what is happening out there? The particle is moving again, like suppose it is moving from p1 to p2 and again p2 to p3, p3 to p4, again it recalls back, or again you can say that it comes back to its original position, it vibrates to and fro motion, and again it comes back to the original position. Next, let us discuss about the third point. So it has elastic in nature, just like the rubber band or the spring, or you can say that like various ropes as well. So third but not the least, due to inertia, what happens? Due to inertia, medium can transfer. Medium can transfer. Medium can transfer kinetic energy, or you can say the kinetic and potential energy both. Potential energy. What happens? What is inertia, my dear students? Inertia is nothing but a object is at rest until unless an external force is applied. Until unless external force is applied. And again, or object the object is in motion. The object is in motion. Object is in motion until and unless it does not change its state until and unless external forces applied. So that is nothing but due to the inertia, there is an involvement of inertia in the mechanical wave, due to which mediums can transfer easily the kinetic energy as well and potential energy as well. Like how you can be having a doubt how, sir, how it is happening like that. So you can like this. You can see here. You can see here. What happens? If it is at rest, if the object is at rest, what is happening? The object is gaining what? The object is getting the potential energy. Object is getting the potential energy. If the object is in motion, what is happening? The particles are in motion. You can say that they are gaining the kinetic energy. So simultaneously, they are what is happening? The particles are moving and again coming back to the original position. Again, it is moving. Again, coming back to the original position. Like you can see here, P1, P2, P3, P4. What is happening at P1? If it is at rest position, it will gain the potential energy. When it will move to the P2 position, it will gain the again when it is in motion, it will gain the kinetic energy. After that, same the process is repeated simultaneously one by one. So you can say that it can transfer the both kinetic and potential energy. So my dear students, for today it is enough. Tomorrow we'll discuss about the that is second wave, that is electromagnetic wave. Today we have discussed about the mechanical wave. Tomorrow we'll discuss about the electromagnetic wave. So thank you for today.